right, we're looking at 11.4, mean absolute deviation, and it begins on page 837. We're going to start with the real world link. It says that the table shows the number of points two teams scored. We've got Allie's team and Lena's team. And number one says it wants us to plot each set of data on a number line. So you're going to go ahead and take the scores from Allie's team and put it on her line, and then put the scores from Lena's team on her line. Go ahead and graph that now. I'd like for you to pause the video. So here's what your number line should look like. Allie's are really like evenly spread out. It looks like they skip count by 2 when you put them in order. And Lena's team kind of bundles on the high side of 40s, low side of 50s, and then also bundles in the high side of 50s, low side of 60s. So we've got 2 little bundles on hers. They want us to find the mean of each data set and then plot those means on the number lines with a star. So go ahead and pause the video now. I'd like you to find the mean for both Allie's team and Lena's team. All right, and what I found was when I added up all the number for Allie's and Lena's team scores, both of them had 440. And so I divided them by 8 because they both had 8 values. And that mean ended up being 55 for both Allie's and Lena's teams. Now it wants us to find the range of the data, each set of the data. So you need to take the largest number and subtract the smallest number for both Allie's team and for Lena's team. And what you should find is that their both largest numbers are 62 and both of their smallest numbers are 48. So they actually have the same range, which is 14. When it's saying refer to the number lines and compare and contrast each of the set of data, like I said at the very beginning, what we notice is that they have the groupings are more spread out on Allie's team, whereas on Lena's team, they're kind of bundled on the low side and bundled on the high side, but they don't have a lot in the middle there. Their mean averages end up being the same, and their ranges are the same. They have the range of the same amount of data. It's just that Lena's is bundled up on the high and low ends of the scale. Find the mean absolute deviation. So now we're going to learn about mean absolute deviation. It says that you have the interquartile range to describe the spread of the set of data, and you can also use the mean absolute deviation. So the mean absolute deviation of a set of data is the average distance between each data value and the mean. So this is now talking about the average distance between each data value and the mean, each data value. So let's look at some examples. Example number 1 says the table shows the maximum speeds of 8 roller coasters. Find the mean absolute deviation of the data set. Describe what the mean absolute deviation represents. So the first step, and I love that they give us step-by-step instructions. The first step is to find the mean. Step 1, find the mean. So they've already done it for us. They added up all the speeds for the roller coaster, and then they divided by 8 because there's 8 values. And they said that value then is going to be 64. Now that's just the mean. That's not the mean absolute deviation. You wish you were done, you're not. Let's go to the next step. Step 2 says find the absolute value of the differences between each value in the data set and the mean. So we just found out that the mean was 64. So the mean is 64. And what we're going to do is find the absolute value of the difference between each value in the data set and that mean. So for instance, we have one value that is 40. So to find the difference between 40 and 64, I'm going to do 64 minus 40, and I get 24. And so that's one of my values. Next is the absolute value of the difference between 64 and 48, and that difference is 16. Then the absolute value difference between 64 and 58, and that's 6. And 60, that's 4. Now, we started with doing mean minus the amounts, but once we pass the mean, now we're going to do the number minus mean, because we don't want any negative numbers. We're finding absolute values. So we're going to take the bigger number and subtract the smaller. So in this case, this number is 64, okay? I'm sorry, 66. So we're going to do 66 minus 64, and that's 2. And so that's our next amount. Then we're going to do the same thing with 72 here. This is 72. So we're going to take 72 minus 64, and we get 8. And we're going to do the next one, 80 minus 16 is going to be, or sorry, minus 64 is 16. 88 minus 64 is 24. So these are our values here. And we're going to go on to step 2. So step 2 was, step 2 was just finding those values, the differences between the mean and all the numbers, okay? And really, we didn't have to look at that number line to do that. We could just take each of these numbers and either subtract 64 from them or subtract them from 64. Okay, so you're not going to have to make this number line like they did. Just want to make that clear. Next, we're going to do step 3, which is finding the average of all the numbers from step 2. So we're going to take 24, 16, 6, 4, 2, 8, 16, 24. We're going to add them all together, and then we're going to divide by how many there are, which is 8. And that answer is 12.5. And that is our answer. Now we're done. That was the answer. That's our mean absolute deviation is 12.5. And what this means is that the average distance each data value is from the mean is about 12.5 miles per hour. So, of course, that's not true for all of them. That's the average between each of the data values and the mean average. That's the average distance. Let's do another example. Oop, just kidding. Don't look at that. Hold on. Okay. Now, there's no reason to go back and write that stuff down. I'm actually going to go over this example with you. Now, if you think you understood how to do the 3 steps from the example and you want to do A by yourself, go ahead and pause the video now. Otherwise, you're about to hear me go over it, okay? All right. So, the first thing is, it says the table shows the speeds of 10 birds in miles per hour. Find the mean absolute deviation of the data. It wants to know what is the average, I should say, what is the average difference between the values and the mean? What's the average difference between the values and the mean? So it tells us that we're going to round to the nearest hundredth, and it wants us to describe what it represents. So, step 1, find the mean. Okay, step 1 was find the mean. And so we need to add up all our values and then divide by how many there are. When I add these all up, it's 786, and there are 10 values, so that's what I'm going to divide by. So my mean is 78.6 miles per hour. That's my mean average. Now step 2, we're going to find the difference. Okay, find the difference between mean and all the values. So we're literally going to take, and I'm not going to do every one of these, but we're literally going to take each of these numbers and either subtract 78.6 from them, or we're going to subtract them from 78.6. It just depends. If it's whatever the bigger number is, it goes on top, whether it's the mean or if it's the 88 or the mean and the 65. Whichever the bigger number is of those numbers, they go on top. So we're going to do that for every single one. And if you'd like to try and do that on your own, you may. If not, I'm going to show you those in just a moment here. Now, you must be super excited that they gave you a decimal number as the mean so that when you're subtracting every single time, there's going to be a decimal value. But here are the decimal values, and I did them in order in case you did it and you'd like to check your work. That's all it is for step 2. Now step 3, we're going to find the average of all the numbers from step 4. Or sorry, step 2. So we're going to find the average of step 2. So we're going to add up all these decimal numbers. Yay, I know. And then we're going to divide by 10 because there's 10 of them all together. And so, again, if you want to pause, you should do that now. When I added them all together, I got that it's 109.2. And I'm going to divide that by 10. And it said to round to the nearest hundredth, which is not necessary. So I find that interesting. But the nearest hundredth would make it 10.92. So 10.92 miles per hour is the average speed from the mean. So each of these values has an average of 10.92 miles per hour from the mean average, which was 78.6 miles per hour. All right, so the average of the difference of the average of the differences between the mean and the values is 10.92 miles per hour. All right, so this is our final answer, 10.92. A lot of work, I know, but it is what it is. All right, so now we're going to compare variation. And it says you can compare the mean absolute deviations for 2 data sets. Ooh, yay. A data set with a smaller mean absolute deviation has data values that are closer to the mean than a data set with greater mean absolute deviation. So for instance, if, let's see, going back, that first example that we did, the mean deviation was 12.5. Yikes, yikes. Okay, and then the last one that we just did was 10.92. And so the lower number means that its data values are closer, it means that the data values are closer to the mean average. Whereas this larger number means that the mean absolute deviation is greater, so they're more spread out from the mean average. So the smaller the number, the closer those values are to the actual mean average, which, you know, if you're talking about grades and you're saying, oh, I got 90 and I got a 99 and a 94 and a 92 and an 88 and an 84, your mean average is probably going to be in the low 90s. And your spread isn't too bad because you got, you know, an 80, you got a couple high 80s, right? Now, if your grades were like 64 on one quiz and a 99 on another one and a 92 on another one and 40 on one, you know, that's going to be a really big difference between the mean average, which is what your real grade will be, and your actual grades. So that's the difference. I hope you understood that. All right, so here's an example. It says the top 5 salaries and the bottom 5 salaries for the 2010 New York Yankees are shown in the table below. Salaries are in millions of dollars and are rounded to the nearest hundredth. Oh, wow. So the top 5 salaries, we've got somebody making $33 million, $24 million, $22 million, $20 million, $16-ish million. And then on the low end, they're not even making a full million. They're not even making $500,000. They're like 0.45, 0.44. So they're making like $450,000, $440,000, $430,000, that kind of thing, okay? Instead of making the cool mills that the top guys are making. So we're going to find the mean absolute deviation for each set of data values. And so the first thing, of course, step 1. Oh, but I lost my color red here. Hold on. Step 1 is to find the mean of the top 5 salaries, and then you're going to find the mean down here for the bottom 5. Okay, so these are both step 1. Step 2 is going to be finding the deviation of each of the 5 salaries. So that's when you found these numbers. Okay, that was step 2. Oops, no. Boop. Okay, so step 2 is to find those numbers. But then to actually find the mean absolute deviation, we're then going to divide, we're going to add those numbers together, those differences between the mean and the actual numbers. We're going to add those all together, divide by how many there are, and this ends up being our mean deviation. So you notice that the mean absolute deviation for the big hitters here, the big guys, the big guns, is over $4 million. That's the difference between the mean and the mean average of these guys and the values of the actual incomes that they're getting. That's the average. Whereas with the guys on the low end of the scale, theirs is just 0.1. So that's like $100,000 difference. When we're talking, you know, going from millions, big money, big money, to, you know, not even, I mean, 100,000, which, I mean, does sound like a lot of money, so don't get me wrong, but, oh no, that's not even 100,000, sorry, that's 10,000. So we're talking just like 10,000. We're just not talking as big of money as we are up here with the guys with the big guns. Their spread is more. You know, you've got one guy making 33 million, you got another guy making 16 million. But over here you've got someone making 450,000 and 410,000. That spread's not too bad. But this, you know, this guy's making like double the less guy on the top 5 salaries. He's making double the salary of this guy right here. This guy is making double the salary of this guy. This guy is making a boatload more than these poor guys right here who haven't made it to the big time yet. So that's just putting it out there. Now, mean absolute deviation. The absolute values of the differences between each data value and the mean for the top 5 salaries are calculated below. So it's just showing you how they figured it out. They found out that the mean was going to be 23.4 million, and so they subtracted it from each of those numbers and found the absolute value. Now, in the case for this and this and this, when you're doing it, you haven't learned how to subtract with negatives, so just make sure that you're taking the big number and subtracting the little number from it, okay? And then you'll find your numbers. All right, so now you're going to do on your own a few sentences comparing their variation. Oh, we already went over that, so sorry, I blew that for you. Oh, that was just B of that. Never mind. Now, doing problem B, it says the table shows the running times in minutes for 2 kinds of movies. Find the mean absolute deviation for each set, and then round to the nearest 100. Then write a few sentences comparing their variation. So running time for comedy movies versus running time for dramas. I want you to go ahead and find the mean absolute deviations using steps 1, 2, and 3 that we just went over a couple times now. You're going to do that for both comedy and drama. So I definitely want you to pause the video now and do this on your own. If there's not enough room, get a separate piece of paper out. Just make sure you bring it to class. All right, pause the video now. All right, so my answers are for the comedy, the mean deviation is 4.16 minutes, and the mean absolute deviation for dramas are 12.24 minutes. And so just comparing their variation, I would write that... I guess I should actually write this down. So if you need to keep copying this, you better pause the video now. I would say based on the mean absolute deviation that comedies, the running time for comedies are closer to the mean average than they are for dramas. But still, 12 minutes isn't that bad, just in comparison. If I'm comparing the two, I would say, let me actually write it. Mean deviation, absolute deviation for comedies. All right, let me start over. So the mean absolute deviation for comedies indicates the running times are closer to the mean than for dramas. Okay. All right, so here's another example. It just says create two sets of data, which each with 5 values that satisfy the following conditions. The mean absolute value deviation for set A is less than the mean deviation set of B. Oh, you know what? So basically, you could use all the numbers from this last one, and you would be making set A the comedies and set B the drama. And if you were doing it the other way around, you'd do drama is A versus comedies B. So, yeah. All right, so if you'd like some more practice, continue listening. If not, you can stop the video now. Number 11, which I don't know if we're on 842 or 843 at this point, calculate the mean absolute deviations both with and without the data value of 55. Round to the nearest hundredth if necessary. So it's saying that this is referring to a table that shows the recorded speeds of several cars on a busy street. We have someone driving 35 miles per hour, 38, 41, 35, 36, and then I just came along going 55. So it's saying let's find the mean absolute deviation with and without the data value and round to the nearest, and it wants to know how including 55 would affect it. Well, I can already look at it and say, okay, well, 55 is a much higher number than the rest of the digits, so it's probably going to make the mean absolute deviation larger for when it's involved than when it's not. So I'm going to go ahead and answer 12, and I'm going to see if I'm right. So including 55 will make the MAD, because I'm tired of writing it out, the mean absolute deviation, I guess I can spell make right, will make MAD a bigger number than without. Oh my gosh, what is wrong with me? Than without. That clearly is a sentence, I swear. Not really. All right, so explain how including the value of 55 affects the mean absolute deviation. I'm saying that including 55 will make MAD bigger than without. So I'm going to now do number 11. And if you want to pause the video now and try it on your own, then please go ahead. Otherwise, you're about to watch me do it. And you can write along, of course. So the first thing is that I need to find the mean. Okay. So finding the mean, I'm going to add up all my numbers and divide by how many there are. So let me do that now. So finding the mean, the first thing I did was add them all up, and it came to 240. I divided by how many there were, which is 6, and I got my mean as 40 miles per hour. So the average speed, including my 55, is 40 miles per hour. I'm going to go ahead and now do the mean when I don't include. So this is going to be the mean when I don't include the 55. And so this will be with me not including 55. All right, now notice that I had to subtract out. I didn't have to re-add them up. I just subtracted out from 240 my 55, and I got 185. When I'm dividing, I no longer have that 55, so now I'm dividing by 5 values, not 6. And so my speed ended up going down to 37 as my average. So originally it was going to be 40 miles per hour as my average. Now it's 37 miles per hour for my average. So now let's go on and do the differences. So finding the differences is step 2. And so for the first one, between my 40 and 35, I've got 5. Between 40 and 38, it's 2. Between 40 and 41 is 1, and so forth and so on. It makes a difference, huh? Whereas when I'm doing over here, now it's 37 that I'm using, and so my differences are just a touch different. I'm now going to do 37 minus 35, which is 2, 38 minus 37, which is 1, 41 minus 37, which is 4, 2, 1, and I'm not including anything else because that's all I have. Now for the next step, we're going to find the MAD. So we're going to add up all of these values and divide by 1, 2, 3, 4, 5, 6 values. And over here, we're going to add all of these up and we're going to divide by 5 values. So I'm going to do that now. If you want to do it on your own, you need to pause. All right. Bad news is, the good news is I did it, but it deleted everything. And the good news is I did it and it deleted. Okay, I don't know. All right. So for the mean deviation, when you include 55, it's going to be 5.3 repeating. And when you don't include 55, the mean absolute deviation is only 2 miles per hour. So like I said in my prediction, I thought that whenever you include the 55 miles per hour, this mean average deviation is going to be larger because you've spread apart. You've got one value that's going from 40 as the mean up to 55, which is the speed limit that they went so fast. So not only does your mean make it your 55 is going to make your mean larger, and it's also going to then in turn make your mean standard absolute deviation also larger. So again, these are the two answers. This is the MAD for each one, with and without. And then, like I said before, for the next question, I thought that that was going to end up being a larger number because if you keep the 55 in there, there's going to be a bigger spread. Okay, and we're talking about spreads. All right, guys, that's it for the video for tonight. I will see you tomorrow or the next day or whatever day it is that you're coming to school. All right, guys, have a great day. See you in school.